We're looking at the main components in our goods market model. We said the first component we want to discuss is total demand for goods or aggregate demand. Where if we go back, so we essentially talked about the total demand for goods is made up of consumption, investment, government spending, net exports. And then we discussed the behavioral assumptions in our standard goods market model, right? Where we said we're assuming a linear consumption function. We're assuming investment, government spending, taxes are exogenously given, and we're looking at a closed economy. And given these assumptions, we looked at this is how we represent our total demand for goods. So now we want to graph our demand schedule given our assumptions in the standard goods market model. So we can plot this demand schedule by drawing a graph with demand on the vertical axis and output on the horizontal axis to illustrate the level of demand at each level of output. Now, in a standard goods market model, with these assumptions that we have over, with these assumptions that we have over here, the consumption is a linear function or disposable income, investment, G&T are exogenously given, and it's a closed economy. So given these assumptions in our standard or basic goods market model, this is our demand schedule. Now over here, we can note that demand is a linear function of y in this case. So its graph will be a straight line in a graph with y on horizontal axis and demand on vertical axis. Now recall general equation of a straight line is y is mx plus c, where m, the coefficient of x, is your slope and c is the vertical intercept. So if we compare it with our equation of our demand schedule, which is also for which the graph is also going to be a straight line because it's a linear function of because z is a linear function of y in this case. So if I compare it to the general equation of straight line, we can easily identify the slope and vertical intercept of the straight line that we will plot in our yz plane. Now here z is being plotted on the y-axis and y is going to be plotted on the x-axis. So the coefficient of y in this case, c1, is going to be our slope. Now our slope is between 0 and 1, as c1 represents MPC, which we're assuming is between 0 and 1. And since the slope is greater than 0, this demand schedule will be upward sloping. Our vertical intercept is our autonomous spending component. We already discussed this earlier. Okay, this is and this is the part of demand that is not dependent upon y. In other words, the amount of demand that an economy will have in income is 0. Now here we're assuming that the autonomous spending is positive. There's only one case where it would be negative, where you have a very large budget deficit. So we can safely ignore that case here. So we're assuming our autonomous spending component is positive. So now if I plot it in a graph with z on y-axis and output on horizontal axis, so we can see this is our demand schedule, z, c plus I plus g. We don't have nx because we're assuming a closed economy. Here the slope is c1, which is greater than 0, so it's upward sloping, and the vertical intercept is our autonomous spending component, which we're assuming is positive. Now, this demand schedule, we'll see a parallel shift in this demand schedule if any autonomous component of demand changes. Now, the autonomous component of demand in this model are T, G, I, and C naught, right? As that will change demand for any given level of Y. So we'll see a parallel shift in this demand schedule if any autonomous component of demand changes, as that would change demand for any given level of Y. And these autonomous components could be C naught, this could be T bar, this could be I bar, this could be G bar in this pattern. Right, so that would cause a parallel shift in the demand schedule because demand increases for any given Y and there's no change in slope, which is C1.